the absolute value function, it's a pretty difficult function to wrap your mind around. How it's usually defined to students is just to make whatever's on the inside positive. Okay, so typically when instructors first start out talking about absolute value, they'll say, okay, we've got a function f of x. So we'll put these little bars around it, and what we mean is that whatever's on the inside, we make it positive. And that's kind of true. Okay. Um, well, I mean, it is true because you're looking for the distance away from zero, but there's some fault in that logic. Okay, so what happens is students will say, okay, well, let's look at some examples, and we'll say, okay, let's say what is f at -3, and so that's the absolute value of -3, and they'll say, okay, let's just get rid of the negative and we'll make it +3. That's true. Okay, and then they'll say, okay, what if we have f at 5? Well, that's the absolute value of +5. There's no negative, so we can just get rid of the absolute value signs and we get 5. And that's also true. Okay, but the formal definition for it is that the absolute value of x is equal to -x if x is less than 0, and it's equal to x if x is greater than or equal to 0. So let's use this definition of it and see what happens. Well, if I say the absolute value of negative, I don't want to use 5 again. Let's use -7. Well, if we define it in terms of this piecewise function, where does -7 fall? Well, okay, so remember, x is just the guy in here. So what this is saying is the absolute value of something is equal to the following. It's equal to negative of that something if that something is less than 0, and it's equal to just that something inside there if that something is greater than or equal to 0. So when I plug in -7, where does -7 fall? Is it less than 0 or greater than 0? Well, it's less than 0. So let me erase this, we don't need this. So this -7 falls into category 1 up here, and so the output is -7. That's what it says. It says take whatever you plugged in here, put it in here. So it's -7. And that gives us +7 because, of course, we know a negative and a negative make a positive. So that's a little bit different. When you think about the definition in terms of this, I mean, it gives you the same result, but it's a little bit different than what people were saying before, just get rid of the negative. So if we say something like -2, well, -2 again falls on this interval right here. It's a number. Here's 0. It's a number on this side. Remember, this guy down here is a number on this side. We'll include 0 here. It really is irrelevant whether you include 0 on whichever one, because the negative of 0 is still 0. So since -2 falls over here, we use this, so we plug it in. And we get 2 out. Now let's try a positive number. Let's say the absolute value of 6. Well, 6 falls on this side. So we're going to use this one. So the absolute value of 6, we just plug in 6 here, and we get out 6. That's it. Okay, well, why is this important? Well, what if you have something like this? Let me erase this now down here. Actually, I'm going to erase all this, give myself some room here. What if you have something like this? The absolute value of x plus 3. Or make it even better. I'll do the absolute value of x minus 3. Here's the mistake students make. They say, well, just make everything positive. So this would be x plus 3. Okay? Now that's not necessarily true. Let's go ahead and talk about why that is. Let's pretend that was true. Okay, so we'll put a question mark here. What if x, I don't know, was something like 2? Now this thing should hold for every x, but watch this. The absolute value of 2 minus 3, that's equal to the absolute value of -1, which is equal to 1. On this side, if I plug in if I plug in 2, I get 2 plus 3, and that's equal to 5. These are clearly not the same. So they are not equal to one another. So how do we get around that? Well, what we've got to do is we've got to say, okay, let's look at x minus 3. When is this whole guy positive. When does it fall in this? And when is x minus 3? When is it negative? When does it fall in this category? Okay. So let me do this with some colors here so that we can differentiate. So this would be this case. This would be this case, because if x minus 3, if what I plug in, remember, this can be replaced with little boxes. So whatever you plug in here, there's a little box, there's a little box. These are your outputs. And I should actually replace these as well. Okay, just like that. So what we need to know is if what we plug in, is that positive or negative? Well, when is x minus 3 positive? Well, let's take a look. X minus 3 is greater than 0 when x, excuse me, I should say it like this. When is it positive? So I should probably use this. This doesn't really matter here. So at 3 or more, we're going to be in this case right here. So here's 3. Okay. And for this guy over here, when is x minus 3 negative? Well, when x is less than 3. Okay, so clearly these two sets are disjoint. They don't have everything in common. And they're on different sides. So here's how we write this. When x is greater than or equal to 3, then the absolute value of x minus 3, that means this guy's positive, so it goes into here and we just get x minus 3 out. When x is less than 3, then the absolute value of x minus 3, then this guy in here is negative, right? If you take a value that's less than 3, let's say 2, then 2 minus 3 is negative 1. If you take any other value that's less than 3, this guy in here is going to be negative. If it's negative, then it's equal to the opposite of what you see on the inside. Just like that. So this is equal to negative x plus 3, or 3 minus x. So you get two answers out. The absolute value of x minus 3 is either equal to x minus 3 or 3 minus x, depending on your initial condition, or depending on where x actually is. Let's try one more. So actually, before I try one more, let me use an example. If x is greater than 4, so let's erase this down here, give myself a little bit of room. Let's say you let x be equal to 4. Then the absolute value of x minus 3 should be equal to, now x is 4, so it's greater than 3, so it should be equal to x minus 3, this guy over here. Let's check. If I plug in 4, I get this, the absolute value of 1 is equal to 1, and we know that that's true. Okay, what if x is 1? Well, if x is 1, that's less than 3, so that means the absolute value of x minus 3 should be equal to 3 minus x. Let's plug it in. This would be 1 minus 3, and this would be 3 minus 1. So this is the absolute value of negative 2, which is 2, and this side, of course, is 2. So notice that these guys are equal, or these guys are equal, depending on what x value you pick. So let's try another one. Let's say we want the absolute value of x plus 7. Well, when is this guy positive and negative? So it is positive under the following conditions. So when is x plus 7 greater than or equal to 0? When is it non-negative, I'll say. So this is when x is greater than or equal to negative 7. So here's negative 7. So as long as my number falls somewhere in here, we're good. Then the number inside here is going to be positive. Like, if, for example, if you pick negative 6, and I plug in negative 6 plus 7, that gives me a positive 1. If I grab negative 2 plus 7 is 5, and that's positive. Any number on this interval will make the inside positive. What about negative? Well, of course, it's going to be the opposite of this. Well, how do we do that? When is x plus 7 negative, that's when x is less than negative 7. Over here. So we've got two intervals now to think about. The first is the absolute value of x plus 7. When it's positive, it's just equal to just the inside. But when it's negative, it's equal to the opposites of what's on the inside. So let's check to see if that works. Let's pick a value that's greater than or equal to negative 7. Like let's, for example, let's let x equal negative 2. Then negative 2 plus 7 should be equal to negative 2. The absolute value of that should be equal to this. So this is the absolute value of 5. This is equal to 5. And of course, these guys are equal to one another. Now let's try this over here. Let's pick a value that's in this. Now if you picked a value over here and you tried it over here, it wouldn't work. Or if you, like if I used x equals negative 2 on this, watch, it won't work. So that's negative 2 plus 7. And this would be negative 2 minus 7. So this would be 2 minus 7 or negative 5. And this gives me, of course, positive 5. See how they don't equal one another? So what I'm saying is if you try to use the wrong formula, okay, the wrong procedure here, you get the wrong answer. Now if I pick a value that's over here, I've got to use this guy over here. So if, let's say I pick x equals negative 8. Then negative 8 plus 7 should be equal to negative 8 plus 7. I can use this or I can use this. Doesn't matter which one I use. And so if you do the math out here, this is the absolute value of negative 1. And this is negative 1. And so this is 1 and this is 1. And they match. If you try to plug negative 8 over into here, it won't work. Watch. Negative 8 plus 7 is not going to be equal to negative 8 plus 7. Because this guy gives me negative 1. And this guy gives me the absolute value of negative 1, which is positive 1. So we have to be careful with absolute value once we start working with things that are not just real numbers. Once we start working with expressions where we have variables or things floating around, we have to use this definition. So be very careful as you proceed, especially once we start talking about epsilon delta proofs, because then it's going to be very important in that portion of the text.